Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Mohammed Bukhamseen, and today I will be presenting my data science project that was made in accordance with the ISE291 guidelines for a data science project. Hopefully this project will fulfill all of the rubrics conditions and requirements, as well as the guidelines to satisfactory ends. The dataset I chose for this project is the soil pollution and associated health impact that was uploaded onto Kaggle by Koshi Yadav. This is a synthetic dataset that includes 3,000 simulated records using real-world scenarios. Now, the reason I chose this dataset specifically is for a few key reasons. This dataset offers a strong real-world context, considering that it uses real-world scenarios as a basis of simulation. Soil pollution is an serious environmental concern, especially in agricultural regions. Understanding how pollution affects not just crops but human health through disease severity makes this dataset both socially relevant and also scientifically valuable. To begin, as you can see, I proceeded with the natural steps taught to us in this course. I imported the necessary libraries in order to start, and I also printed out a few columns the rows needed for the actual regions, just for transparency. Now, in accordance with the actual guidelines provided to us, this dataset does not have any actual missing observations or inconsistencies. So I went forth to the actual data preparation phase with the mindset of including the actual data cleaning steps, as if there were any actual missing data or inconsistent data. So here, starting from this cell, I filled the numeric supposed missing data with the mean values of the actual pollutant concentration, and I used the disease severity category in order to fill any missing categorical disease severity spots using the mode values. Then I fixed inconsistencies, should there be any inconsistencies, for example, replacing or fixing the actual region row with the actual name of the region instead of the country. And I also implemented the interquartile method in order to remove any outliers in this dataset. I then moved on to discretization, and I started with the actual pH value for the soil samples. I separated it into three distinct categories: acidic, natural, and alkaline, based on the actual pH scale. And I then used the same method in order to define three categories of pollution levels: low, medium, and high, with the present specifications. Finishing off the phase 2 of the project, I implemented one hot coding and turned the disease severity data in this dataset from categorical datasets into numerical datasets, and this was implemented in order to use this data to draw and plot graphs that will be presented shortly. I then implemented min-max normalization for temperature and z-score normalization as well for temperature for added accuracy. Now moving on to phase 3, I explored the dataset using the various plots I mentioned earlier. I started with printing out numerical and categorical summaries for the columns of the dataset. I added these just for clarity or just in case reviews were needed in order to verify the actual data for the graphs present in this project. The histogram shown before you is a histogram of pollutant concentration. It shows us pollution values that are distributed across all samples. This helps check for any skewness or extreme concentrations. As you can see, the lowest possible value is somewhere between 0.003 and 0.004. And the actual bins for the histogram plot is divided into 50 bins because of the actual vast amount of data. Moving on, we can see two bar plots. These are bar plots of the soil pH and pollution levels. As you can see, the most common category of pH categorization is the acidic type in this data set, with the alkaline and neutral being somewhat equal at around 780. As for the actual pollution levels, the medium pollution levels, as can be seen here, numbers between 50 and 150 are the most common, with the low and high being almost equal. Moving on, the scatter plot between polluted concentration and soil organic matter is not exactly the most helpful. The reason the actual dots of this plot are scattered is due to the vast amount of data and as well due to the vast extremes of the dataset. There aren't any particular trends present within the pollutant concentration, all the actual organic matter of the soil samples present within the dataset, which is why the scatter plot looks scattered. Moving on, the box plot present is the pollutant concentration by pollution level, which categorizes the pollution level, like we've seen before, into medium, low, or low, medium, and high. Low being the lowest in the polluted concentration, medium being somewhere in the middle, and high being having the highest amount. Moving on, we now move on to multivariate visualizations. This pair plot shows relationships across multiple numerical features, including temperature, as can be seen here, humidity, soil pH, and polluted concentration. In order to keep this plot readable with 3000 samples, I used sampling and made points semi-transparent. The heat maps of the correlation matrix shows how each numerical variable correlates with each other. As can be seen here, and here, they are almost overlapping entirely in the soil pH and temperature and humidity. Moving on to phase 4, I planned and built my model, and I started by first dropping the features that could leak into the label, which I achieved by dropping the actual dummy variables I converted from categorical data types into numerical data types. keeping only the numerical columns compatible with the scikit-learning model. I then reconstructed the original target and then moved onto preparing the data, training it and testing it in order to model the tree plot that will be shown shortly. I used an 80-20 training and testing datasets, which is a standard practice in this course. Then I imported the necessary libraries in order to display the confusion matrix, classification report, and accuracy score of the data. As you can see here, from the printed results, the precision, recall, F1 score, and support for this data is not the most accurate. It achieved an accuracy score of 36.17%. I visualized the actual findings of this entire project in this tree plot. I kept the maximum depth of the tree up to 3 only. I did this in order to make it easier to understand and present the data. Now moving on to phase 5, the communication of results. As you can recall, these are the actual stats or findings of the dataset and the actual data model I used for this project. Here are the conditions, or here are the conditions present for my actual modeling evaluation. Moving on to phase 6, the operationalize phase. This is more of a concluding phase, and in this phase I would like to say that in conclusion, while the actual phase itself or the model itself is not highly accurate, I believe that this project demonstrates a full data science pipeline or a full representation of what we learned in the ISE291 course. Some of the limitations and challenges that were present in this course were, of course, the actual vast amount of the data, as I've mentioned before, and that can be seen from the scatter plots. The enormous amount of data caused a lot of problems with the visualization of plots, which made removing the outliers all the more important as to normalize the data, and even still trends were quite often than not very difficult to discern from each other, barring the actual pollution concentration within the soil samples. Additionally, the low accuracy of this model suggests or indicates that while it is functional on a operational grounds, the actual model itself needs a lot of work and improvement in order to increase the accuracy of such studies. It is true that the dataset is synthetic, but it is simulated using real-world scenarios, so there is a lot of improvement that is necessary. And finally, during the actual coding of this project, I faced a lot of problems with the class confusion being mild or severe, likely due to overlapping environmental data, as well as data leakage between or when it came to reconstructing the data from categorical or from numerical data back into from categorical data back into numerical data. Thank you for listening to my explanation of the data model for this project, and assalamu alaikum wa rahmatullahi wa barakatuh.